In this video, we're going to cover one-step equations. Solve one-step equations by performing the opposite operation. So if you see multiplication, you would do division. If you see addition, you would do subtraction. Check your answers by substitution. This is going to make sure that you're doing the correct process. So the first example we have is 75 equals 5z. We need to solve for z. We have an implied multiplication between the 5 and the z, so this is a multiplication process. We need to isolate the variable we're solving for by doing the opposite operation. So we're going to divide both sides by 5, which is the opposite of multiplying by 5. When we do that, 5 divided by 5 is 1, and so we have just 1z. But in math, we usually don't keep the 1. We just assume it's there in a little invisibility cloak. And so z equals 75 divided by 5. And that's just 15. So now we need to check our answer. To check, we replace the z with 15. So we have 75 equals 5 times z, but z we said was 15, and we just need to make sure that this becomes a true statement. 75 equals 5 times 15. Is that true? Well, 5 times 10 gives you 50, and 5 times 5 gives you 25, so 75 equals 75. So yes, this is a true statement. In example 2, we have 7/8 times t equals 112. There are two different ways we could do this. We could multiply by the reciprocal, which is the best option, and I'll explain why here in a second. Or you could multiply by 8 and then divide by 7. Both are great options, but we're going to do it all at once. So since this t is being multiplied by 7, because we can think of the t as over 1, and divided by 8, we could do the opposite by multiplying by 8 and dividing by 7. But whatever we do to one side, we have to do to the other. Some of you might be wanting to multiply straight across for your rules of fractions from way back. So 7 times 8 is 56 over 56 t, but 56 over 56 is just 1. So we can just write this as 1t, but wait, 1t is just t, because remember in math we don't write the 1 in front unless it's critical. So we have a t there. On the right side of this situation, don't forget to put your equal signs in. We have 8 times 112, but that's over 7. So now we need to think about 112. If we take 112 and divide by 7, 7 goes into 11 one time with 4 remainders. Drop the 2 down. 7 goes into 42 6 times with 0 remainders. So we have a 16 times 8, and we divided out the 7. Now, if I lost you on that step, let me just show you one other way to think about this. From this statement up here, we know that 7 times 16 equals 112. So I'm going to put 7 times 16 in place of the 112 times 8 all over 7. And now since the 7 over 7 is equal to 1, I can reduce those out. So I have t is equal to 16 times 8 as my solution. Well, 16 times 8 is 128, so t equals 128. And now we have to check it. I'm going to replace my t with 128. So 7/8 times 128 equals 112. Now we need to see if this is true. So now I'm going to multiply 7 times 128. Now think of this 128 as over 1, if that helps with the processing. 128 from up here we know is 16 times 8. So I can rewrite this as 7/8 times 16 times 8 over 1. My 8s will divide out because 8/8 is just 1. Let's see, 7 times 16. Does that equal 112? Well, we'd have 70, 7 times the 10 there, and 7 times 6 is 42. So 70 plus 42 does equal 112, so we're good. Check.